Hello everybody, this is Kusai Kaneda, a student in California State University Northridge in the Department of Computer and Electrical Engineering. I'm having this video today because I wanted to show you guys one of the very interesting tools and commands that have been existed in the software of Matlab, and it's simply a kind of command that gives a very efficient and a very easy kind of analysis for any transfer function or any control system that have been given to us. And as for example, if we get these two standard transfer functions to be on the symbol form of having no zeros and some balls at the bottom, and we try to get a look on this command, which is known as the LTI View. And if we ask Matlab to give us help with this command, it will refer to something similar to this. It is the kind of linear time invariant viewer that gives an interactive graphical interference and analysis of time, frequency, and whatever kind of analysis we need to know. And I need to explain some of the characteristics of this code, or characteristics of this command. So pretty much it can give different kind of analysis in a way. If we ask to be given a step or an impulse kind of input for the function, we would need to find the response for the input. And these two commands, if they've been attached to the LTI view command, they will give a very nice shipped out output of the system response. As we can see here, we have the linear simulation plot and the initial condition plot, and these are two kind of different simulation for the actual function building. It's like the actual plot of having different kind of points for whatever input and output we have to receive. And as for the initial condition, it's very important. If we've been given a differential equation and we were asked to find the transfer function for that differential equation, the change in the initial conditions would have a very huge uh, difference in the output of this transfer function. As for the body plot, and that is very familiar for the very familiar kind of name for the frequency response. The blood plots give two plots of the magnitude and the phase difference of different frequencies over time for the given transfer function. As for the Nyquist and Nichols, they both give this different other representation of the frequency response, but it's very important to know that when we when we add the busy map, we can find the zeros and the balls of the transfer function, and that is very important kind of analysis to understand is this system stable or not stable. Just to give an example about how we can use this command, we'll do something similar to this. So if we get the LTI view of T1 and T2, it will take the very basic kind of analysis, and that is this step input. And as we can see, here's the T1 and T2. We can give different titles. We can give different kind of colors or kind of distinguishing between the two inputs. But how is this code really interests us? It's in here where we can use very different analysis with different characteristics for the same transfer function. As for example in here, we can see that this is the step input. As we can see in the code, we still have the step input as the first analysis. We still have the body, and we have the Nyquist analysis. As for the busy map, we can see clearly the position of the two balls of the system. And from all of these analyses, we can get a very efficient and less effort and less time consuming analysis of any given transfer function for any given control system with just the use of one single command, and that is the LTI view. This is what I saw very interesting, and this is what I wanted to share with you guys. Thank you very much for your time, and I hope this was a little bit helpful. Thank you.